Are you willing to let a humanoid robot drive a car? Meet Musashi, the robot developed by researchers at the University of Tokyo that's doing just that. Musashi is a musculoskeletal humanoid designed to mimic human anatomy, complete with anti-slip feet and dexterous hands. It can turn a car key, pull the handbrake, and even switch on the turn signal. Equipped with 2 cameras as eyes, Musashi can see the road and check side mirrors. It can press the accelerator and brake pedals with its mechanical feet. The researchers taught Musashi to use the steering wheel by feeding it raw sensor data, allowing it to navigate through intersections and obey traffic signals. Impressive, right? Now, before you head down to the comments section and start hating on this robot, I will warn you, there is plenty room for further development. Nonetheless, this robot is autonomously driving this car. Watch how it approaches this turn in the intersection. Musashi only slightly lifted its foot off the brake to turn a corner instead of using the accelerator, making the turn painfully slow. Like 2 minutes slow. In another test, it used the accelerator but struggled to maintain a consistent speed, especially on inclines. I'm pretty sure your grandma takes that turn faster than Musashi, and clearly there's room for improvement. But the researchers are already working on the next-gen version of Musashi, aiming for better performance and reliability. But at the end of the day, the car is being driven by an autonomous, independently thinking AI robot. Boom! Mind blown. Now, let's dive into how they taught Musashi to drive. Using a neural network called DDC-Net, or Dynamic Direct Control Network, the team created a system that understands the time series relationship between control inputs and task states. This means Musashi can adapt its movements based on real-time feedback, just like a human would. They started with random control inputs to gather data and trained the network to predict the robot's actions and outcomes. In practical terms, this allows Musashi to perform tasks with greater accuracy and efficiency. For example, during pedal control experiments, Musashi used a basic PID control, which is just a standard controller that engineers use to control temperature, flow, pressure, etc., and it initially showed slow response times. By incorporating acceleration estimation and dynamic control, the robot improved its performance significantly. The task-specific self-body controller acquisition method they developed ensures that Musashi can learn and adapt quickly, making it a versatile and intelligent driver. Imagine Musashi in a real-world scenario. A humanoid robot taxi driver in Tokyo, navigating the busy streets, adhering to traffic rules, and ensuring passenger safety. While we're not there yet, the potential is enormous. The researchers are already envisioning future applications where Musashi can handle more complex driving tasks, from smooth acceleration to precise braking, and even navigating through heavy traffic. This technology isn't just making a robot drive. It's about enhancing the robot's ability to interact with and understand its environment. Here's a prediction for you. If Musashi ever goes mainstream, and by mainstream, I mean driving Uber, driving New York taxis, etc., it's going to need the ability to interact with humans. What's the most advanced generative AI tech out there right now that would allow this to happen? Exactly, GPT-4o, and potentially its successor, GPT-5. And honestly, there is a theme we're seeing in the industry: AI robotics teaming up with advanced generative AI companies. AI robots will need the generative AI technology, and if they don't have it themselves, they will need to partner with someone who has it. Now, the broader implications of AI robot autonomous driving are profound. Autonomous driving is a field with immense potential, and having a humanoid robot like Musashi behind the wheel could revolutionize the way we think about transportation. It combines the precision of robotics with the adaptability of human-like control, potentially making our roads safer and more efficient. The goal isn't to replace humans, but to enhance our capabilities and improve safety and efficiency in ways we couldn't imagine before. The researchers are already envisioning future applications where Musashi can handle more complex driving tasks, from smooth acceleration to precise braking, and even navigating through heavy traffic. But the road ahead is not all flowers and rainbows. there is still a lot of trust to be gained before the general public feels safe in a car with these AI robots. I think we're all still a little shaken up from when the autonomous vehicle company Cruise hit a pedestrian, then threw the person into the oncoming lane, and dragged them a few yards. Wow. And yeah, that wasn't too long ago. But if you're going to embrace AI robotics, we all recognize the technology is going to slowly improve day by day. In fact, the same technology used to teach Musashi to drive is being applied to other critical tasks. Whether it's in healthcare, manufacturing, or disaster response, robots like Musashi could be performing tasks with a level of precision and reliability that complements human capabilities. But let's not get ahead of ourselves. The journey to perfecting Musashi's driving capabilities involves understanding and improving its musculoskeletal structure. The robot's complex body, inspired by human anatomy, includes a flexible spine, ball joints with singular points, and fingers with multiple degrees of freedom. This design allows Musashi to perform intricate tasks, but also presents significant challenges in terms of control and coordination. To address these challenges, the researchers developed a method called Task-Specific Self-Body Controller Acquisition. This method enables Musashi to learn and optimize its movements for specific tasks by directly representing the relationship between control inputs and task states. It's like giving Musashi a personalized training program that helps it become better at driving with each practice session. In their experiments, the team used a small electric vehicle called B.com Delivery for testing Musashi's driving skills. The setup included power supplies for the robot's logic and motors, batteries, and Wi-Fi router for communication. The researchers conducted the experiments indoors to ensure safety, with the car's rear drive wheels placed on free rollers and the front wheels fixed by stoppers. One of the most impressive aspects of this research is the ability of Musashi to adapt to different driving conditions. The robot's control system can adjust its movements based on real-time feedback, ensuring that it can handle various road conditions and driving scenarios. This adaptability is crucial for autonomous driving, where unexpected changes in the environment are common. Looking ahead, the researchers are exploring ways to enhance Musashi's capabilities further. This includes improving the robot's sensor systems to provide more accurate and comprehensive data about its surroundings. By integrating advanced image processing and machine learning techniques, Musashi could gain a better understanding of its environment, allowing it to take more informed decisions while driving. Additionally, the team is working on refining Musashi's control algorithms to achieve even greater precision and efficiency. This involves developing more sophisticated models that can account for the complex interactions between the robot's muscles and joints. By doing so, they hope to create a control system that allows Musashi to perform tasks with the same level of dexterity and fluidity as a human driver. The potential applications for this technology extend far beyond autonomous driving. The principles and techniques developed for Musashi can be applied to a wide range of fields, from manufacturing and healthcare to disaster response and exploration. Imagine a humanoid robot that can assist in search and rescue operations, navigate hazardous environments, or even provide personalized care for the elderly and disabled. In the field of healthcare, for example, robots like Musashi could assist in surgeries, providing steady and precise movements that enhance the capabilities of human surgeons. In manufacturing, these robots could handle delicate assembly tasks with unmatched accuracy and consistency, improving production efficiency and product quality. The integration of AI and robotics also opens up exciting possibilities for personalized services. Imagine a home assistant robot that can understand and respond to your needs, whether it's preparing a meal, cleaning the house, or providing companionship. With the ability to learn and adapt, these robots could become a good buddy to hang out with, or maybe our best friends. So, what do you think? Would you let a humanoid robot like Musashi drive your car? Leave your thoughts in the comments below, and let's keep this conversation going. And if you want to stay updated on the latest in robotics and AI, make sure to subscribe to our channel. Until next time.